Hello dear students, welcome to Tejama YouTube channel. So in this session we are going to discuss about a new concept in the chapter electric charge and fields for competitive perspective, that is motion of charged particle in electric field. Okay. So here if I consider the first case wherein the charged particle enters the electric field, here there is a electric field. When you consider a positive charge is placed at rest, initially it is at rest. So, let us consider electric field is E and the velocity of the charged particle is 0 initially. So, it experiences a force in which direction? In the direction of electric field. If in case if I place a negative charge at rest in electric field, it experiences force in this direction. So, what is that force is equal to? Force is equal to Q into E, yes or no? Since the charge is always associated with mass, ಈ ಚಾರ್ಜ್ಗೆ ಮಾಸ್ ಸಹ ಇರುತ್ತೆ ಅಲ್ವಾ? So I can consider this is having some mass m, charge q, mass m, charge q. Therefore, from Newton's second law, I can write F is equal to QE, that is equal to ma. Now, acceleration produced by this electric field on the charged particle is given by QE by m. Okay. So, what is the expression for acceleration produced by electric field on a charged particle of mass m? This is the answer. A is equal to QE by m. Now, if I apply this one to equations of motion, let me write, we have V is equal to U plus AT. So, what is U? Initial velocity is 0, A is QE by m. If it is an electron, you can write minus E. If it is a positive charge of magnitude E, you can write EE by m into T. So, velocity is given by QE by m in terms of time. Okay. If in case, if you consider velocity in terms of displacement, we have V square is equal to U square plus 2A, S you can write, X you can write, Y you can write. In which direction is it moving? Let me consider it is moving along X axis. So, initial velocity is 0. So, V square is equal to 2A is QE by m into displacement X. So, V is equal to what? Square root of this one. Then you can write the kinetic energy gained by the charged particle. Okay, kinetic energy gained by the charged particle, that is kinetic energy is equal to half mv square. So, first one, kinetic energy in terms of time, if I consider, I will substitute this half m. What is V? QET by m. So, that becomes Q square E square T square by m square, because V square is there, m get cancelled. So, kinetic energy in terms of time is given by Q square E square T square divided by m along with 2. This is very important formula for competitive examination. Okay. Next we have kinetic energy, that is in terms of displacement. You can write S, X, Y, whatever it may be, that is equal to half m V square, that is half m. What is V square? 2QEX, 2QEX divided by m. Okay, so get cancelled, 2 get cancelled. So, we will get kinetic energy is equal to QE into X. This E into X is nothing but V, Q into V. So, like this you will get one more formula for kinetic energy in terms of displacement or potential. Okay, this is about first case. Now, let us take second case where we consider the charged particle enters perpendicular electric field. And one more thing here. So, if I consider the charged particle just placed in electric field, in which direction does it move? It moves in a straight line. That means the trajectory of the particle is a straight line, because the charge particle either moves in this direction or moves in this direction. It moves in this direction or it moves in this direction along this straight line. Now let us discuss what if the charged particle moves perpendicular to electric field. B. Okay, so let me consider there is a plate to which some positive charge is given. Okay, so here we have another plate given with negative charge. Okay, ಇದಕ್ಕೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಕೊಡ್ತೀವಿ, ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದು ಕೊಟ್ಟಿದ್ದೀವಿ. Now if you consider the direction of electric field, okay, so let's consider this is the direction of electric field, correct? No, this is direction of electric field. Now here if I consider a charged particle, which one, positive charge particle enters the electric field in this direction with initial velocity u, initial velocity u. So because plus plus repel each other, plus minus attract each other, it will move like this. Yes or no? It moves in this direction. So this is called the deflection produced by the external electric field. Why? Why is the deflection produced by the external electric field? How much is that? We measure it in terms of angle. So at this particular point, the velocity in this direction is v. What is the velocity in this direction? Okay, so and what is the angle here? If I consider, I can make or I can create a draw a angle there. So there is external what is that velocity in this direction, v. So in this direction I can take the component of v along x-axis, that is v cos theta. In this direction I can take, or in this direction also take, this one is equal to this one. So therefore what I will do is I will take here, that is this is velocity v cos theta, this is v sin theta, correct? No, so or let me consider this is velocity along x-axis and this is velocity along y-axis and this is theta. If I want to calculate this theta, so I will take tan theta is equal to, what do we get? Vy by perpendicular by base Vx. So these two are very very important. I need to derive an expression for y and Vy and Vx. Shall we do it? Yes sir. So electric field, if I consider, I will divide this into two parts. One is along x-axis and one is along y-axis. X-axis and y-axis. What is the displacement along x-axis? Displacement you can take it as x only, or you can consider it as what is it, L also. Here displacement is x. What is the displacement along y-axis? Y. Next, what is the acceleration along x-axis? X-axis there is no force acting at all. So acceleration along x-axis is 0. No force is acting along x-axis. Only the force acting along y-axis is electric. And here we are learning this in the absence of gravity. Okay, gravity free space. Gravity free space. This we are learning, discussing in the absence of gravity. Otherwise there will be a force mg also. So in this direction no force acting, downward the positive repel each other, so it moves downwards with a force. So acceleration along y-axis, we have just derived the expression for electric field, acceleration due to electric field, that is Ey is equal to QE by m. Correct now? Now what about the velocity? Velocity along x-axis. So that is u. And what is the velocity along y-axis? So that is Vy, you can take. But initial velocity is okay. Initial velocity along x-axis is u. Initial velocity along y-axis is 0. Initial velocity along y-axis is 0. I need to find out final velocity, where here. Since final velocity along x-axis, here if you consider at this particular point, so there is no force acting in this direction, right? The horizontal component of velocity remains constant, u only. But vertically, you need to consider Vy is equal to velocity along y-axis, initial velocity along y-axis plus, you can take square also, or at also you can consider. What is that? V is equal to u plus at. V is equal to u plus at. So V is equal to, initial velocity is 0. So A into t. What is acceleration? Velocity along y-axis is equal to A is QE by m into t. So by using this, I can derive tan theta. So tan theta is equal to Vy is QE by m into t. Vx is u. So theta is equal to tan inverse QET by mu. Clear? This is theta. Sir, what about the deflection y value, sir? One more equation is there. That is equation of motion, x is equal to ut plus half t square, right? Along x-axis, you can take x is equal to u is ut plus half at square is not there. So because acceleration along x-axis is 0, so t is given by x by u. Time taken to reach from here to here or to reach from here to here is same. Now if I use it for y-axis, y is equal to u, that is velocity along, initial velocity along y-axis, ut plus half a y into t square. Y is equal to, initial velocity along y-axis is 0 plus half, what is this? Ay is QE by m into t is x by u whole square. So this will be the value of y. Okay, half q e x square divided by mu square. So if initial velocity is constant, e is constant, q is constant, m is constant, 2 is constant, y is directly proportional to x square. So that's why it moves in parabolic paths. That's why the trajectory is of particle is parabola. Yes or no? Parabola. This moves like a parabola. This will be asked in your competitive examinations. So then, sir, if y has to be more or if it has to be less, which factors matters a lot? If y has to be more or it has to be less, it depends on this ratio, that is q by m. Q by m is called the specific charge. Q by m is called specific charge. If specific charge is more, deflection will be more. If specific charge is less, deflection will be less. So let me write that here, directly proportional to q by m, that is called specific charge. There is a question based on this in NCERT. Shall we discuss about that now? Okay, hope it is clear to you. If you get any doubt, do let me know in the comment section. I will explain this in detail further. Okay. Now let me take the example. NCERT question. Okay, just a minute. Yes, hope it is clear. Now we are going to discuss about the example question, right? Here we have a positive plate and here we have a negative plate. So there is a electric field downwards. So I will throw few particles into this region. One particle, let's consider this particle 1 moves in this direction, particle 2 moves in this direction, particle 3 moves like this. So we have to find 1, 2, 3. What is the polarity of charges? Of course, the one which get attracted towards the positive charge is the negative charge, right? This is 1 is negative, 2 is also negative, and 3 should be positive. Which one is getting deflected more? This one is getting deflected more, right? This charge particle is getting deflected more. That means what? This is having more specific charge, that is charge per unit mass of third particle is more. After that, first particle is getting deflected more. Q by m of first particle is greater than Q by m of second particle. So this specific charge matters a lot. To find the deflection, whether it is more or less, can be found by using this formula. Okay. At last we have one more important JEE mains topic, that is, what if the charged particle, the projectile motion in electric field when the charged particle enters the perpendicular electric field. Let me discuss about this. See, so here there is an electric field like this. Now if I throw a positive charge in this direction, what happens? It will move and moves in this direction. Yes or no? Because this is the positive charge, if it moves in this direction, there will be force acting downwards, right? No, sorry, this is negative charge. So negative charge means this side there will be negative charge, with electric field applies force opposite to its direction on the negative charge. So it comes downwards. So if I consider this is positive charge in the direction of electric field, it moves in this direction. If I consider negative charge, it moves opposite to it. So if I throw the charged particle with some initial velocity u, making an angle theta with this, what happens? This electric field pushes the negative charge downwards. Okay. Now if I consider what is the initial velocity along x-axis and initial velocity along y-axis. Initial velocity along x-axis is Vx is equal to u cos theta. Initial velocity along y-axis is u sin theta. U sin theta. This is initial velocity, you can write it as ux. Initial velocity along y-axis uy. Okay. So after this, after coming here, okay, so you can see here there is a parabolic path, projectile motion is there. So we need to discuss about this. What is the acceleration along x-axis? There is no force acting along x-axis, so it will be 0. Let me take this side, I will consider x-axis, this side I will consider y-axis. So along x-axis acceleration is 0, along y-axis acceleration is qE by m. Of course negative charge means minus qE by m. Then we have, what is this, velocity. Velocity along, at any point you can consider the velocity. So velocity along, initial velocity I have already given here. So after some time, if you consider, so velocity along x-axis will remain same, it will not change. Velocity along x-axis will remain same because there is no force acting, so u cos theta. But if you consider velocity along y-axis, it will change because of opposite force. So that is v is equal to u plus at, velocity along x-axis plus velocity, this is y-axis, vy into t. Okay, so that is vy is equal to uy is u sin theta, acceleration is qe by m into time taken. Okay, then let us discuss about displacement now. Displacement along x-axis is given by this complete thing. So that is given by velocity. Since velocity is equal to displacement by time, so here displacement you can use x is equal to ut plus half at square. So velocity along x-axis into t plus half a t square. Acceleration is 0. So displacement is equal to u cos theta into t, because velocity along x-axis is u cos theta, into t. So t is how much? U divided by, sorry, x divided by u cos theta. Correct, no? X divided by u cos theta. Now what is displacement along y-axis? This is very, very important. So displacement along y-axis is equal to ut plus half at square along y-axis. Along y-axis, what is the initial velocity? U sin theta. What is time period? X by u cos theta, x by u cos theta plus half ay is qe by m into t is x by u cos theta, u square cos square theta. So y is equal to sin theta by cos theta is tan theta into x plus half qe x square divided by m u square cos square theta. So like this we get an equation, so which is similar to the equation of parabola. That's why here also the trajectory of parabola projectile is parabola. Okay, so this is about this. So that is the motion of charged particle in electric field. 3 different cases I have explained till the JEE mains level. So keep practicing. If you feel the content is useful, please share it to your friends. See you in the next video.